Good afternoon, class. We are looking at Module 3, practice test covering chapters 5, 6, 7. Chapter 5, trigonometric functions. Chapter 6, periodic functions. Chapter 7, trigonometric equations and identities, also known as analytic trigonometry. So here's chapters 5 and 6, trigonometric functions and periodic functions. All right. We are going to convert degrees to radians and vice versa. So reminding you that one easy way is to look at it. D over 180 is R over pi, because pi is 180 degrees, and you can replace any one that is given. For example, you can put the degrees here in this case. Cross product, find the missing R. Or for the degrees, you can multiply by pi over 180. For the radians, the reciprocal of that, 180 over pi. So in this case, either way will do the job. So 315 times pi over 180, or you can say 315 over 180 equals R over pi, and do the cross product. That means the same thing, okay? And you end up with 7 pi over 4. Convert 9 pi over 5 radians to degrees. Then times the reciprocal of that, 180 over pi. Remember, 180 degrees is equal to pi. This ratio or this ratio, both are unit conversions, okay? And so when you do that, the pi cancel out, of course. 180 is divisible by 5, 9 times 36 gives you 324 degrees. Convert 3 radians to degrees, so you're going to multiply 3 times 180 over pi, which is 540 over pi. And again, this is exact. But most likely we are going to write it in this fashion as 171.899, 0.89 degrees. 14 pi over 3. We know that all trigonometric functions are periodic. All of them have a period of 2 pi, except tangent, and therefore cotangent have a period of pi. So all you have to do, when you see a number larger than 2 pi, subtract multiples of 2 pi, like 2 pi, 4 pi, 6 pi, and so on. So to bring it down to just one complete revolution from 0 to 2 pi. And then you make a decision. So notice 14 pi over 3 is 12 pi over 3 plus 2 pi over 3. The reason we go 12 pi over 3 because this is multiples of 2 pi, that's 4 pi. And therefore, this is the same as 2 pi over 3. So sine of 2 pi over 3. And remember, I discussed the reference arc. I hope you recognize this, having the reference arc pi over 3. So that is the same as sine of pi over 3. But as far as positive or negative, you look at the quadrant. 2 pi over 3 is in quadrant 2. Sine is positive in the first and the second quadrant. So square root of 3 over 2. If it's easier for you to recognize because you have memorized it in degrees, notice 2 pi over 3 is 120 degrees. And if you go this route, then the reference arc is 60 degrees. Either way, makes no difference. All right, let's do this one. Answer the following question. name the quadrant that contains the terminal point of the arc t equals 2, justify your answer. So let's discuss it in general. So we have a unit circle. A point P has coordinates x, comma, y, and x represents the cosine, y represents the sine. This is theta equals 0 degrees or radians. This one, theta equals 90 degrees or pi over 2 radians. Theta equals pi over 180 degrees. Theta equals 3 pi over 2 or 270 degrees. So we are dealing with the unit circle, as I mentioned, x squared plus y squared equals 1. Sine is y, cosine is x, and tangent is y over x, and the rest of them are the reciprocal of those also, right? Tan is y over x or sine over cosine. Cotangent is x over y or cosine over sine. Cosecant is 1 over y or 1 over sine, and secant is 1 over x or 1 over cosine. Pi over 2 is about roughly 3.14 divided by 2 becomes 1.57. Pi is about 3.14 and 2 pi is about 6.28, just to give you an idea. So in the first quadrant, t is between 0 and pi over 2, roughly 1.57. In the second quadrant, pi over 2, t is between pi over 2 and pi, between 1.57 and 3.14. In quadrant 3, it's between pi, which is 3.14, and 3 pi over 2 is about 4.71. In quadrant 4 is between 3 pi over 2, which is 4.71, and 2 pi, which is 6.28. So what was this number? 2. So all you have to do, look at the numbers. And 2 is here, between 1.57 and 3.14 clearly. So answer is quadrant 2. Find the exact value of cosecant 11 pi over 2. First of all, we take multiples of 2 pi out. Secondly, we notice the reference arc is pi over 2, all of the above. So we take 8 pi over 2, which is 4 pi. It's the same as cosecant of 3 pi over 2. And when it comes to cosecant and secant, just go to the respective reciprocal. So cosecant is 1 over sine. So it's the same as 1 over sine of 3 pi over 2. And you should know 3 pi over 2 sine is negative 1. So 1 over that is negative 1. So that's easy to figure out. Determine the length of arc of a circle and area of a sector formed by the central angle theta if theta is 1/2 radian and r is 10 meters. Well, recall, this is S equals r theta. This is the sector. Area is half of r squared theta. So a couple of simple formulas we should remember. So in this case, S equals r theta. And theta must be in radians. So multiply the two numbers. And obviously the answer is 5 units of the radius. 5 meters, units of the radius. Area is half of r squared theta. Plug in. Half of r squared, which is 10 squared times theta, which is 1/2. 1/2 and 1/2 is 1/4. This is 100. So 100 divided by 4, which makes it 25 units of the area, meters squared. So whatever the radius is squared. And of course, that really, as far as the units, you can say 10 meters and you see that. So whatever we do two numbers, we do 2 units. The central angle is 60 degrees, or is 5 feet, and we are going to do the same thing. However, the first thing is this has to be in radians, and you know it's a common arc pi over 3, or just multiplied by pi over 180. S equals r theta. 5 times pi over 3 is precisely 5 pi over 3 units of the radius in feet, and this is an approximation. This is exact, everybody. Always answer the exact, and if need be, you go to the approximation. Area is half of r squared theta. We plug in half of 5 squared is 25 pi over 3, and I hope you recognize 25 pi at top, 6 at the bottom. Exact answer. Putting it into a calculator gives you 13.090 square feet. Very straightforward, everybody. We are going to move on, making sure everybody is following everything. Each wheel of a car with a radius of 15 inches makes 3 revolutions per second, RPS. Revolutions per second, revolution, 2 pi radian each one. How fast is the car moving in mph, miles per hour, or linear velocity? Reminding everybody that 1 mile is 5,280 feet. So the question is, what is given? So you're dealing with an application problem. You want to write down what's given and then go to the symbolic format and solve the problem. So the radius r is 15 inches. 3 revolutions per second. That angular velocity omega equals 3 rps. And the linear velocity v is missing. So linear velocity is defined as distance over time, which is s over t. When we go over in a circular pattern, s over t. Omega is the total angle over total time, theta over t, or 2 pi times rpm or rps, depending on the units of time. It could be even rp d per day, revolution per day could be. Whatever that, no, that one is the units of time, rp, revolution per revolution. A complete revolution is 2 pi. 2 pi times whatever that one is. And v is s over t. S, we replace it with r theta. We separate the r. Theta over t is omega. V becomes r omega. This is to remind you how we found the relationship between linear velocity v, angular velocity omega. So now the given r is 15 inches, omega is 3 rps, v, the linear velocity, is missing. So the very first thing we do, we say 3 times rps. Revolution means 2 pi radians. So 3 times 2 pi makes it 6 pi radians per unit of time. Whatever the unit of time is, sticks around. Okay, in this case, it's seconds. But understand, revolution means basically 2 pi. That's all. A complete revolution, 2 pi radians. That's why we multiplied by 2 pi, regardless of this is per second, per minute, per hour, whatever. V equals r omega. The linear velocity is the same thing times r, and r is 15. So 15 times 6 pi, which is 90 pi, and that would be units of the radius, 90 pi inches per second. So we have the answer. However, we want it in miles per hour. That's what we want. So what do? We are going to write 90 pi inches per second. It's supposed to change. This is supposed to go away and become miles per hour. One mile is 5,280 feet. Just to give you an idea, this concept of a unit conversion, reminding you, just a side note here, and then unit conversion means if I said 1 mile over 5,280 feet, or if I said 5,280 feet over 1 mile, they are both unit conversion, everybody, unit conversion. But you have to figure out what you need, okay? So just for the sake of argument, if you look at that one and nothing else, since the miles is at top, that means 1 mile must be at top. Do you follow what I'm saying? Just to give you an idea. But this is in inches, and you know 1 foot is 12 inches. So you can say 1 foot over 12 inches, or you can say 12 inches over 1 foot. In fact, let me write both of them. I want to make a point here. You have a choice of writing 1 foot over 12 inches or 12 inches over 1 foot. They are both unit conversion. So I want the unit inches go away. If it's at top, they can't cancel each other. So it has to be at the bottom. So I hope you see this is not the case, but rather this is the case, because this inch cancels out this inch. So I hope you see what I'm talking about when it comes to unit conversion. Now we're going to continue with the rest of it. So I'm going to erase this. So inches, I'm going to write 1 foot or just foot over 12 inches. I'm going to put mile over 5,280 feet. And then I need hours. This is seconds. So I put the hour at the bottom. You know, 1 hour is 3,600 seconds, or you can say 60 seconds times 60 minutes. So foot, 12 inches, mile, 5,280 feet, 60 seconds over 1 minute, 60 minutes over 1 hour, or in one shot, you can write 3,600 seconds over 1 hour. These two you can put them in this format. Okay. And when you put them all together, meaning 90 times pi times 3600 divided by 12 divided by 5280 becomes 16.065, almost 16.1 miles per hour. That's the idea, everybody. If the length of an arc S is 50 inches in a circle with a radius of 6 inches, find the angle theta this arc subtends. So what is given? S is 50 inches. Radius is 6. So S and R are given. And we know S equals R theta, and theta is missing. So what do? Theta is S over R. Theta is S over R. And that makes it 50 over 6. 25 thirds radians. We want to find the area. Area is 1/2 R squared theta. So 1/2 R 6 squared theta 25 thirds. I hope you see that 2 times 3 is 6. 2 times 3 is 6. So it cancels out one of them because it's 6 squared, 6 times 6. So 6 times 25 is 150 inch squared. Units of the area. Very straightforward, everybody. Find the linear velocity of a cylinder with a 2 feet radius that is spinning at 40 miles per hour. For the RPM, revolutions per minute, my apologies. For the RPM. Okay, so R is, let's write down what's given. R is 2 feet. Omega is 40 RPM, revolutions per minute. Linear velocity V is missing. So given R is 2 feet, omega is 40 RPM, velocity, linear velocity is missing. So plug in. We know first and foremost, omega is 2 pi times RPM, RPS, you name it. So 2 pi times 40 makes it 80 pi radians per minute. So the reason you change it, one revolution, a complete revolution is 2 pi radians because you want to go with the radians. That's why. So we have omega and V is R omega. So plug in R is 2, omega is 80 pi. And the answer is precisely 160 pi feet per minute. And use a calculator to guesstimate it, if you will. And I'm going to write down this is the exact answer. Always have your exact answer. Okay, everybody? Make sure you have the exact answer always. Find the exact value of each of the remaining trigonometric functions of theta, given that tan theta is minus square root of 3 over 3, and sine is positive. Reminding you of a couple of things. This is a unit circle, x squared plus y squared equals r squared, and this is a general form, x squared plus y squared equals r squared. Both of them centered at 0, 0. This one has a radius 1, this has a radius r. And as you recall, for the unit circle, x represents cosine, y represents sine. When the radius is no longer 1, and x squared plus y squared equals r squared, and p, let's say, is being represented by a or b or x or y, sine is y over r, cosine is x over r, tangent is y over x, and the rest of them are the reciprocals, if you want to go with that format. So that's just reminding you of what we had. Now, if we want to go with that, we have to figure out the quadrant, the value of x, y, or r, whatever that is given. First and foremost, we notice that tan is negative. Tan is negative. It's quadrant 2 or 4. Sine is positive. Quadrant 1. Quadrant 2. Therefore, the answer is quadrant 2 because that's the common quadrant. So tangent is negative, everybody. Sine is positive. That gives us quadrant 2. Theta equals 5 pi over 6. And you can go with that. That's a common arc. And the reason it's not 5 pi over 6, remember, tan is minus square root of 3 over 3. If you go with the reference arc, tan of theta is square root of positive square root of 3 over 3 when it's pi over 6, when theta is pi over 6. And then in the second quadrant is pi minus that. Okay, that's how we arrive at 5 pi over 6. It's a common arc. You should know that. So we know the rest of it. Okay. So if it's 5 pi over 6, okay, just for the sake of argument, sine. First, let me just discuss this one more time. So if you go with tan of theta being positive, this is reference arc. The reference arc becomes pi over 6. And so the values are just like pi over 6, of course, in the second quadrant. For example, sine of 5 pi over 6 is the same as sine pi over 6, which is 1/2 positive or negative, and the second quadrant is positive. Cosine of pi over 6 squared of 3 over 2 in the second quadrant is negative, so on and so forth. If we want to stick, so we can go with the common arc. Or if we want to write tangent is y over x, in the second quadrant, y is positive, x is negative, so x is minus 3, y equals 3, and now plug in. Now, before you plug in, you have to find the rx squared plus y squared equals r squared. Negative 3 quantity squared is 9. This one is 3. They add up to 12. And you should know 12 is 4 times 3. 4 comes out as 2. So if you want to stick with that, just plug in, okay, sine is square root of 3 over 2 square root of 3 or 1/2. But like I said, it's a common arc and we should know sine is 1/2. The rest of them, you can go with that fact, or you can go with the fact that we found x, y, r. We have x, we have y, we have r, plug them in, and sine is 1/2, cosine is negative square root of 3 over 2, tangent, it was given. Cotangent is the reciprocal of that, negative square root of 3, cosecant is the reciprocal of that 2, and secant is the reciprocal of that minus 2 square root of 3 over 3. So whatever is fast there is fine, as long as you can justify your answer. That is good enough. You can also use identities from time to time if need be. That's ultimately your choice unless otherwise mentioned. Find the exact value of each of the remaining trigonometric functions of theta given that secant is 2. Secant is positive, just like cosine, and sine is negative. Remember, in the fourth quadrant, this happens because secant, okay, let me just write it for secant, just like cosine. For secant to be positive, just like cosine would be quadrant 1 and 4. Sine is negative in quadrant 3 and 4. So the answer is quadrant 4. Secant is 1 over cosine, is positive. Sine is negative, and that's what we get. Quadrant 4. And needless to say, that means cosine must be 1/2 the reciprocal, right? So we use identities. Sine squared plus cosine squared is 1. And sine squared is 3/4. Sine is plus minus the square root of 3/4. And we decided sine, we are given actually, sine is negative, so minus square root of 3 over 4 is square root. And 4 comes out as 2. So the reason we choose negative, because it's in the fourth quadrant. The rest of them are easy, okay? Cosecant is the reciprocal of this number. Minus 2 over square root of 3. You can rationalize by multiplying by square root of 3 over square root of 3. By the way, this is also a common arc. You can figure out the arc and take it from there, okay? In any event, tan theta is sine over cosine. So the ratio of the two, sine is negative square root of 3 over 2, cosine is 1/2, so we get negative square root of 3, and cotangent is the reciprocal of tangent, 1 over tan theta, which is 1 over minus square root of 3, or rationalize it to negative square root of 3 over 3. By now, everybody knows this means can multiply this one by square root of 3 over square root of 3 to get this one. So that's pretty straightforward, and you can write all of them. In order to organize your work, you can write all of them if you like. It's your choice, everybody. Okay, so just this is for the sake of organization, if you like to do so, not that you have to. It's helpful when we do that, everyone. We want to simplify, and we are aware of fundamental identities as well as common arcs. So pi over 4 is a common arc. A secant is 1 over cosine. We know cosine is square root of 2 over 2, and we know cotangent is 1. And so this flips over, becomes 2 over square root of 2. And I think I've shown you before 2 square root of 2. If you just divide this one here, the product of these two is 2, or just rationalize it. Either way, I hope you can see this fast. It will speed up the process. Sine theta plus cosine theta over sine theta minus cosine theta minus sine theta over cosine theta. We want to simplify it, so we start with the least common denominator because we are dealing with the two fractions. So how do we combine the fractions? We just take the common denominator. So what is the common denominator? Just sine times cosine. That's all. So what happens? This times this minus this times this. Now, when you multiply these two, you get sine squared. I'm sorry, sine theta cosine theta plus cosine squared. When you multiply these two, don't forget the minus. Sine theta cosine theta, and we have a negative. So maybe on this one, and then maybe I write this one. If I multiply this one by sine, I get sine theta cosine theta minus sine squared. The reason I'm writing this one, because this will change the sign. So this becomes negative, this becomes positive. This is just sine theta cosine theta plus cosine squared. Sine theta plus cosine, sine theta cosine theta plus cosine theta squared minus sine theta cosine theta and plus sine squared. I hope you can see that, class. Okay, so that's the change that happens, and I'm hoping that everybody can see that. So what happens? Let's see. Sine theta cosine theta and negative sine theta cosine theta, they are opposites, they cancel each other. And remember Pythagorean identity, sine squared plus cosine squared is equal to 1. 1 plus tan squared is secant squared. 1 plus cotangent squared is cosecant squared. And therefore, whether we write sine squared or cosine plus cosine squared in any order makes no difference. They do add up to 1. And so 1 over sine theta times 1 over cosine theta results in cosecant theta times secant theta. So that's how you simplify. Very simple, everybody. I want to simplify sine squared plus cotangent squared plus cosine squared. Again, reminding you of the Pythagorean identities. Let's put sine squared next to cosine squared. And the reason we do that, because we know sine squared and cosine squared can be replaced with 1. Also, 1 plus cotangent squared is cosecant squared. And now we are done. Cosine of power 6 times secant of 13 power 6. Well, all trigonometric functions, it was mentioned that are periodic, and the period is 2 pi for all of them except tangent and cotangent is pi. And so this one, everybody, is the sum of 12 pi over 6 and pi over 6. Why 12 pi over 6? Because this is 2 pi and you can drop it. So secant of 13 pi over 6 is replaced by secant of pi over 6 because it's a complete revolution plus pi over 6. And as you know, secant is 1 over cosine. So cosine of pi over 6 divided by cosine of pi over 6 is equal to 1. Cotangent theta plus cotangent of theta minus pi, cotangent of theta minus 2. As you know, cotangent is periodic with a period of pi, so multiples of pi, positive or negative makes no difference. This is still cotangent of theta, and so is this one. If I say minus or plus pi or 10 pi or 20 pi or 15 pi or 17 pi makes no difference. It makes a difference if the negative is in front of a theta. Okay, I want you to know that. So we have 3 of those. Find the amplitude, period, intercepts, and phase shifts of the function. Sketch the graph of a complete period where y is given as negative sine pi over 3x plus 4. So first, let me remind you how we graph sinusoidal functions. A sinusoidal function has 1, 2, 3, 4 arcs. So y equals sine x. The period is 0 to 2 pi. Complete cycle goes from 0 to 2 pi. And we use the key points by cutting this into 4 sub-intervals. 0 to pi over 2, pi over 2 to pi, pi to 3 pi over 2, and 3 pi over 2 to 2 pi. And what happens is very simple. We have 0, 0 here, pi over 2, 1, pi 0, 3 pi over 2 minus 1, 2 pi 0, and these are the key points. What is the domain? All real numbers. What is the range? Negative 1 to 1. What is the t to pi? What is the amplitude? A equals 1. Now, if you want the entire function, instead of a complete cycle, complete period, you go indefinitely on the left and right. That's what happens. If we write it in this format, we take the b out, or we may write it in this format. The omega is taken out. And in this case, t, the period is 2 pi over b or 2 pi over omega. The amplitude is the absolute value of a. PS, short for phase shift, horizontal displacement is c over b or phi over omega. If c is negative, phase shift is to the left, and if it's positive, it's to the right. And again, as I mentioned, 2 pi over omega. It depends on how you write it. All right. Note, the midline of a function is the horizontal line midway between the max and minimum value of a function. So for a basic sine is the x-axis, y equals to 0. For sine theta, the midline is the line y equals 0, the horizontal axis. And in general, the midline y equals this. So if it's been shifted up or down, there is a different midline, okay? So that's the, in essence, that's the horizontal shift that we are talking about. The midline for this one is the x-axis, but now with the +4, it's been shifted up by 4 units. And that means the midline now it's y equals 4 for this one, okay? So first, I wanted to give you the synopsis of what we need, and now we are going to go graph this, okay, everybody? All right, so we're looking at the same question, and again, the format that you write it, it's doesn't matter, okay? You write it as a sine b times x minus c over b plus d, or write it as a sine omega x minus phi over omega plus b. Understand the concept. So with that being the case, what do we need to do? First and foremost, the amplitude is the absolute value of this number, which makes it +6. The period t is 2 pi divided by this number, 2 pi divided by omega, or 2 pi divided by b, or 2 pi divided by pi over 3, which gives us number 6. So instead of going from 0 to 2 pi, it's going to go from 0 to 6. And we are going to cut this into 4 equal parts. There is no phase shift. So this is 6. There is no phase shift. Divided by 4, you get 3/2. Which means we're going to go from 0 to 3/2, and then 3/2 to add 3/2 becomes 3, and then 3 to add 3/2 to 3 becomes 9/2, and then 9/2 add 3 becomes 6. So those are the 4 sub-intervals. So 0 to 3/2. Now from 3/2 add 3/2, you get 3. From 3 add 3, you get 9/2. 9/2 and 3/2 is 12/2 or 6. So let's go with the endpoints. 1.5 is 3/2, okay, class? It's everybody knows it's 3/2, okay? 1.5 is 3/2, okay? 4.5 is 9/2. And we want to evaluate them, and I want to stick with this part, ignore the +4 for now. So we're going to ignore the +4 for now. That's a vertical shift. So plug in 0. Let me, okay, if you plug in 0 here, sine of 0 is 0, so this is 0. If you plug in 1.5, it's easier to go with 3/2. If you put 3/2, 3 cancels each other. So let me just show you for 3/2. If I put 3/2 here, it's just here, -6 sine of pi over 3 times 3/2 equals -6 sine of pi over 2. Everybody knows sine of pi over 2 is 1. So -6 times that is -6. If I put 3 here, times pi over 3 is pi, sine becomes 0. If I put 6 pi over 3 is 2 pi, becomes 0. 4.5 or 9 halves. Let me show you 9 halves. If I put 9 halves, I get minus 6 sine of pi over 3 times 9 halves. Minus 6 sine of 9 pi over 6, 3 pi over 2. As you know, sine of 3 pi over 2 is negative 1. So their product is positive 6. So those are the pairs. And all you have to do, plot those pairs carefully. So let me erase my work. So plot 0, 0, 3, 0, 6, 0, 0, 0, 3, 0, and 6, 0. Plot the other two. 1.5, negative 6, 4.5, 6. So this is 1, 2, 3. This is 1.5. This is 3, 4, 4.5. And so that's the graph. This would be a complete cycle for this guy. There's a vertical shift. That means those points, just shift them up by how many units? 4 units. So same x coordinates, the y coordinates become 4, minus 2, 4, 10, 4. So y equals 4, shifts everything up. The midline is y equals 4, okay? That's what I was mentioning. So the same numbers for the x, the y add them, and they become the new points. And that's the graph shifted up by 4 units. Very straightforward, everybody. I hope everybody's fine with that. And by the way, you can, they're asking for one complete cycle. You can continue indefinitely on both sides if they ask you. So we are going to look at this slightly differently, meaning the amplitude is the same, 2 pi over omega, 2 pi over b. The amplitude is 6 and the period is the same. So this is being repeated. Okay, I don't want to spend too much time on that. So this is just like the previous page. There is no phase shift. We cut it into 4 equal parts. We get 3 halves. The 4 subintervals. So far, being identical. Okay. So these are the points. The end points again, 1.5 is 3 halves, 4.5 is 9 halves. Okay. For y equals minus 6 sine of power 3 times x, we've done these calculations. Again, you can go back to the previous page. We did that. And at the same time, for the vertical shift of 4 units up, we just put the same numbers and we add 4. So this becomes 4, negative 2, 4, 10, 4. Okay, so very straightforward. Now, if we want to continue on the left side, in other words, not on one complete cycle, more on the left side, you can continue with those numbers and go to the left by 3/2. So to the left of 0 by 3/2, negative 3/2 or negative 1.5. To the left of this number, negative 3, negative 4.5, negative 6, and you can plug it back and come up with the answer for those as well. So this is y equals 4. These are the points that we are going to put in, and by that, I mean actually these points. Okay, so in essence, think about this line as your x-axis. Okay, so that's the first one. That's the second one. That's the third. Those are the 3 x-intercepts that have been shifted up by 4 units. And then those 2 points, the mean and the max, put them together. That's the graph. What it does this in one shot. If instead of one complete cycle, they said just graph it, they didn't mention one complete cycle, what would you do? You would go indefinitely on both sides. That would be the way to do it. So I wanted to show you that. Question number 12, find the amplitude, period, intercepts, and phase shift of the function. Sketch the graph of one complete cycle where y is 2 cosine of 3x plus pi over 2. And again, remind you of everything that we have seen. First and foremost, we take number 3 out. The result is that this becomes x, this becomes pi over 6. So pay attention that when you take the 3 out, if you put it in 3x, 3 pi over 6 is pi over 2. So that's something you want to be very careful of, everybody. So you take number 3 out. The amplitude doesn't change, it's 2. Absolute value of 2 is 2. T is a 2 pi over 3 because it's 2 pi over b or 2 pi over omega. And the phase shift, now this is minus pi over 6 because it's going to shift to the left by pi over 6. Now we're going to cut the t into 4 equal parts. We're going to divide this by 4. We get 2 pi over 12 or pi over 6. 2 pi divided by 2 pi over 3 divided by 4. Multiply the 4 by 3, you get 12. 2 pi over 12, pi over 6. So those are the 4 parts. Each sub-interval has this width. So this one would be normally from 0 to 2 pi over 3. We are going to add this number. That means subtract pi over 6. So we are going to go from minus pi over 6 to minus pi over 6 plus 2 pi over 3. And I hope you recognize this as 4 pi over 6 with minus pi becomes 3 pi over 6. 3 pi over 6. Let me just write that. This is, and you add them up, 3 pi over 6, which is pi over 2. So And we are going to start with this and go to the right, add to it this much, this much, this much. So if I add power 6, I'll go from minus power 6 to 0. Then I add power 6, 0 to power 6. Then I add power 6 to power 3, and one more, power 3 to power 2. So those are the 4 subintervals. Again, you start from this one. You end up with this one, okay? In this case, pi over 2, okay? So you start with minus pi. So you add, so you start from 0, add pi over 6. Now you start from pi over 6, add pi over 6, you get pi over 3. You start from this endpoint pi over 3, you add pi over 6. So that's how it's going to work. Okay, everybody? All right, so now the x coordinates are these 5 key points: minus pi over 6, 0, pi over 6, pi over 3, pi over 2, and we plug it back into this one or this one, whatever is easier. So first of all, if I want minus pi over 6, is easier. If I put it here, I get 0. 3 times 0 is 0. Cosine of 0 is 1. So this is 1 times 2. So I hope you can see you can get 2 here. So if I plug in, so if I replace this with minus pi over 6, I get 2 times 1 or 2. If I plug it with 0, if I plug in 0 here or there, makes it over here, maybe is a 0, gives you pi over 2. What is cosine of pi over 2? Everybody should know it's 0. 2 times that makes no difference. Let's put pi over 6. If I put pi over 6 here, maybe it's easier to put it here. 3 times pi over 6 is 3 pi over 6, or pi over 2, and pi over 2 is pi. So let's actually show that one. I'm going to show, let me see, pi over 6. If I put it here, everybody, what do I get? Let me just write it there. I'm going to erase this later on. I get 2 cosine. So when I put pi over 6 times 3, I get pi over 2, and pi over 2 is pi. So 2 times cosine of pi, negative 1. So we get minus 2. If I put pi over 3, and again, it's easier to put it here. If I put pi over 3 here, 3 times that makes it pi, plus pi over 2 makes it 3 pi over 2. I get 2 cosine of 3 pi over 2. You should know 3 pi over 2 cosine is 0. Times 2 remains as 0. Pi over 2. If I put pi over 2, and again, it's easier to put it here. 3 times pi over 2 with pi over 2 is 4 pi over 2. So 2 cosine of 4 pi over 2. That means cosine of 2 pi. And cosine of 2 pi, you should know it's 1. So we get 2. And those are the answers. So you can do it in your head. You can show work. It's up to you. I'm going to clean up my mess. And I'm going to plot those pairs. Minus pi over 6, 2, 0, 0. Pi over 6, negative 2. Pi over 3, 0. Pi over 2, 2. So that's how you are going to break down your domain and range. And you put them together. This is the graph. If they didn't ask for a complete cycle, you can go indefinitely on both sides. Okay, for example, for 2 pi over 3 and 5 pi over 3, you can calculate and continue indefinitely. So continue on the left, continue on the right if need be. That's not the case here. We just want one. complete cycle. But that shouldn't be a problem. Again, making sure that everybody's fine with that. So we are ready to move on, everybody. All right. We want to graph. We want to find the domain and range and intercepts and vertical asymptotes of the function. Sketch the graph of one complete cycle where the function is y equals tan of 1/2 x. Reminding you of y equals tan x means sine x over cosine x. The period for tangent and cotangent is only pi. Domain. Whatever makes the denominator 0, excluded, you know, odd multiples of pi over 2, 2n plus 1 times pi over 2, that means odd multiples of pi over 2 makes it 0. So domain is all real numbers except those. So this becomes VA, vertical asymptote. X-intercepts at n pi 0 because where the numerator is 0. X-intercept when y is 0. A fraction is 0 when the top is 0. Sine x equal to 0, n pi comma 0. So all you have to do as far as the change that you make with this one, if the period is pi, they remain the same. If not, you change the location of a pi in each case. For example, here, we know t is pi over b, or omega divided by 1/2 makes it 2 pi. So how do we make the changes here, class? I want to make sure we understand that. T is pi, now it's 2 pi. And we look at this one, we put the t here. So if you replace this one with 2 pi, I just want to show you. If you replace this one with 2 pi, these two cancel each other. So you get 2n plus 1 times pi. The same thing here, if you replace it with 2 pi, these two cancel each other. And if you replace this one with 2 pi, you get 2n pi, just for the sake of argument. So the domain, all real numbers except 2n plus 1 times pi. Range is all real numbers, that doesn't change. Vertical asymptote, we mentioned it's here, 2n plus 1 times pi. And for one period, a complete cycle, x equals minus pi, x equals pi. Remember, for this one, a complete cycle goes from negative power 2 to power 2. Remember that? And the vertical asymptotes are x equals minus power 2 and x equals power 2. In this case, we have the vertical asymptote x equals minus pi, x equals pi. So a few points. So we have those vertical asymptotes. Let's plug in the easy one. 0, of course, gives you 0. Minus pi over 2 changes this one to minus pi over 4, makes it negative 1. Pi over 2 changes this one to pi over 4. Pi over 2 makes this pi over 4, and that's 1. So those are the easy pairs, everybody. So this is x equals minus pi, x equals pi. This is minus pi over 2, negative 1, 0, 0, pi over 2, 1. The scale along the x and y axis, they don't have to be the same, okay, class? And you put them together, and that's your graph for complete cycle. You can continue indefinitely on both sides if you like. Find the amplitude, period, intercepts, and phase shift of the function and sketch the graph of one complete cycle. Y is given as 3 cosine pi x minus 4. So what do we do? First and foremost, the amplitude is 3. Absolute value of 3 is 3. The period is 2 pi divided by pi, makes it 2. I don't see any phase shift. That means sitting something next to that. And of course, we do have the vertical shift of -4. That means if you graph this, just bring it down by 4 units. That's the concept. So we can deal with it just the way it is. We're going to cut the t into 4 equal parts. That means we're going to cut this into 4, and that gives us 1/2. Which means we go from, and there's no phase shift, we go from 0 to 1/2, 1/2 to add 1/2, 1, 1 to 3/2, 3/2 to 2. Those are the 1, 2, 3, 4 subintervals and 5 key points. So there's a vertical shift of d 4 units down. Now let's plug in, this is an easy evaluation. If I plug in 0 here, I get cosine of 0, which is 1. So 3 times 1 minus 4, I get -1. So I can, instead of dealing without that and graphing it and then shift it down by 4, let's just plot those pairs. Those are easy points. If I put 1/2, I get pi over 2. Cosine of pi over 2 is 0, so this goes away, -4. If I put 1, let's just, for example, show 1. If I put 1, I get 3 cosine pi times 1 means pi minus 4. Cosine of pi is -1 minus 4, I get -7. If I put 3/2, 3 pi over 2 is 0, cosine is 0, so just -4. If I put 2, let's also show 2. So if I put 2, let me use a different color. If I use 2, okay, I get 3 cosine 2 pi minus 4. Cosine of 2 pi is +1. So 3 minus 4, I get -1. So those are the numbers. I hope nobody has any problem with those. Okay, so that's easy evaluation. So we start with y equals -4 to just locate that. Let me erase my work, by the way. And then we have 0, okay, -1, uh, 0, -1. This is the x-axis, this is the y-axis. Locate the 0. I hope you can see that. So this is the x-axis. This is the y-axis. It may be hard to see just for the sake of argument. 1/2 -4 is here. 1/2 -4 is here. 1 -7 is here. 3/2 -4 is here. 2 minus 1. That's the graph. Again, let me clean up mine so you can see that. Okay, so this is y equals -4. 0, -1, 0.5 or 1/2 -4. In other words, if you look at 1/2 and 3/2, that would have been like x-intercepts if we didn't have those shifted down by 4 units as it was. And the rest of them, very straightforward, everybody. Find the domain and range and vertical asymptotes of the function. Sketch the graph of one complete cycle. Y equals cosecant pi x. Reminding you that cosecant is 1 over sine. So for a basic one, x can't be n pi because that makes the denominator 0. The ranges are real numbers except numbers between -1 and 1. The way we write it from -infinity to -1 union 1 to infinity. And it's an odd function, just like sine. Remember, all trigonometric functions are odd except cosine and therefore secant. T is 2 pi. Vertical asymptote, whatever makes the denominator 0, x equals n pi, x-intercept, we don't have it. So to graph this, we're going to ignore it and we're going to graph sine. So we're going to graph y equals sine pi x. So we're just going to pay attention to that, which means the amplitude is 1. The period is 2 pi divided by pi, makes it 2. There is no phase shift. We're going to cut this in 4 equal parts. 2 divided by 4 gives us 1/2. It's just like the previous page gives us this 4. Remember the previous page. 0 to 1/2, 1/2 to 1, 1 to 3/2, 3/2 to 2. We had, in the previous case, we had a 3 times cosine pi x minus 4. So the 4 parts works out the same. And so let's look at the key points, the end points. So at 0, if I plug in 0, sine becomes 0. If I plug in 1/2, pi over 2, what is sine of pi over 2? 1. If I plug in 1, sine of 1 pi or pi is 0. If I put 3/2, sine of 3 pi over 2 is -1. If I plug in 2, sine of 2 pi is 0. So again, all of them are very simple. Hopefully nobody has any problem with those. And so we plot those pairs. First the intercept 0, 0, 1, 0, 2, 0. Then the maximum at 1/2, 1. The minimum at 3/2 minus 1. That's the graph of a sine. And of course, if need be, you go indefinitely on both sides. You flip this over and you graph cosecant. That's all there is to it. Let's discuss the domain and range and so forth. Domain, x can't be in pi. In essence, you change this one is half of the period. Okay. The period is 2, so half of that is 1. So it's just n times 1. So domain x can't be 1. And by the way, you flip it over, it looks like that. So x can't be n. Range doesn't change. All real numbers except anything in between -1 and 1. And the writing is the same. Vertical asymptotes, x equals n. When you have this one, x equals n. For example, for a complete cycle, x equals 0, x equals 1, x equals 2, those would be the vertical asymptotes of y equals cosecant pi x for one complete cycle or period.